Have you ever noticed something strange about photographs taken in space? Whether it's footage from the International Space Station, a spacewalk, or even the Apollo moon missions, one detail always seems to stand out. The background is almost completely black. No stars, not even a single point of light. But that raises an obvious question. If the universe is filled with billions of stars, where did they all go? For decades, this mystery has fueled conspiracy theories. Some people claim space agencies are hiding something from the public, while others argue that the photographs themselves can't be trusted. But the real answer is far less mysterious and far more fascinating. To understand why stars often disappear from space photographs, we need to look at how cameras work, how human vision responds to light, and what astronauts have actually experienced beyond Earth. One of the best examples comes from February 7, 1984. On that day, astronaut Bruce McCandless made history aboard the Space Shuttle Challenger. Wearing a jet-powered maneuvering unit, he became the first person ever to float freely in space without a safety tether connecting him to a spacecraft. As he slowly drifted away from the shuttle, surrounded by the vast emptiness of orbit, he famously joked, "Maybe for Neil it was a small step, but for me it's one giant leap." The moment was captured in a photograph that would later become one of the most iconic images in the history of space exploration. Yet when people looked closely at the picture, they noticed something unusual. Behind McCandless was nothing but darkness. No stars, no glowing points of light, just an endless black void. To some observers, that seemed suspicious, but astronauts later explained that the photograph accurately reflected what they often saw in orbit. And the reason comes down to a simple concept: exposure. Every camera controls how much light reaches its sensor. If more light is allowed in, the image becomes brighter. If less light is allowed in, the image becomes darker. It's a balancing act that photographers deal with every day. The challenge in space is that the subjects being photographed, astronauts, spacecraft, and even Earth itself, are often sitting in direct sunlight. And sunlight in space is extremely intense. Stars may be incredibly bright, but they are also unimaginably far away. Compared to an astronaut illuminated by direct sunlight, the light reaching a camera from distant stars is relatively faint. As a result, cameras are usually adjusted to properly expose the astronaut or spacecraft in the foreground. When that happens, the much dimmer starlight becomes too faint to register in the image, causing the stars to disappear into the black background. If photographers were to increase the exposure enough to capture the stars, the astronaut and spacecraft would become completely overexposed, appearing as bright white shapes with little visible detail. In other words, the stars haven't vanished. The camera is simply prioritizing the brighter subject. This isn't unique to space. The same thing happens on Earth. If you've ever tried photographing someone standing under bright daylight while also capturing faint stars in the sky, you've encountered the exact same problem. And when scientists intentionally use different camera settings designed for low light conditions, stars become visible again. In fact, many astronomical photographs taken from orbit reveal breathtaking fields of stars, distant galaxies, and colorful nebulae spread across the universe. But this leads to another question. If cameras struggle to capture stars under certain conditions, why do astronauts sometimes report that they can't see stars with their own eyes? The answer lies in the way human vision works. Much like a camera, the human eye constantly adjusts to surrounding light levels. In bright environments, the pupils become smaller to reduce the amount of incoming light. In dark environments, they expand to collect more light and improve visibility. When astronauts are aboard the International Space Station or standing on the moon's surface, they are often surrounded by intensely illuminated objects reflecting direct sunlight. Their eyes adapt to that brightness, making faint starlight much harder to see. Several Apollo astronauts later explained that during daylight conditions on the moon, they could barely see stars with the naked eye. The lunar surface itself was simply too bright. However, there was an important exception. When astronauts moved into deep shadow and allowed their eyes time to adjust to the darkness, stars gradually began to appear. The stars had always been there. Their eyes simply needed enough time to adapt. This is something we experience on Earth as well. During the day, the stars remain above us even though we can't see them. Not because they've disappeared, but because brighter light overwhelms our vision. The same principle applies in space. Looking ahead, future lunar missions may provide an even more spectacular view of the universe. Astronauts exploring the Moon's south polar region will encounter areas that remain in permanent shadow. In these incredibly dark environments, far from Earth's atmosphere and free from light pollution, the night sky could appear more spectacular than almost anywhere humans have ever observed. After enough time for their eyes to adjust, astronauts may witness countless stars, distant nebulae, and entire galaxies stretching across the darkness in extraordinary detail. So why don't we see stars in most photographs taken in space? The answer isn't a hidden secret, a government cover-up, or a flaw in the images themselves. It's simply the result of how light, cameras, and human vision behave in an environment unlike anything we experience on Earth. The stars were never missing. We just weren't looking at them under the right conditions.